Hello.
Hi, sir.
Hello.
Can you hear me, sir?
Yes, yes. Yeah, I can hear.
Sir, today we'll be doing questions or like electric field of hollow cylinders or like that.
Yes, we will discuss the questions on the electric field calculation. Okay. Line charge, ring we have discussed. So for the ring,
Yeah, we
for
should be discussing of thin rod, hollow cylinder,
yes,
sphere, and all those. No, this
yes,
class
yes.
or next class, or we'll do numericals in this class.
This class first we will discuss about the ring. Okay.
Ring we did it.
Rod. Yes. So ring, arc, circular arc we will discuss. Okay. Then we have the thin rod is there. So for that we will discuss. Disk is
Okay.
there. For that we will discuss. Okay.
Yes, sir.
And after the Gauss law, na, we'll discuss about the hollow sphere and cylinder.
Okay,
Okay.
sir.
Sphere and cylinder we will discuss it after the Gauss law.
Yes, sir.
Did okay? Did they forget about the class?
I don't know, sir.
Yeah. Now Ram Charan also joined. Lokesh. Actually, let's just start now. Okay. Let me just put it. Okay. Let's just start now. So electric field we were discussing, isn't it? Electric field calculation. So for the point charges we have calculated, right? And for the ring we have calculated. For the ring we have calculated on the 2 points, right? The 2 points where one was the center, other one was the axis, isn't it? And we discussed also about the dielectric constant, isn't it? Dielectric constant we discussed, no? Right. Coulomb's law we discussed here. Superposition principle we discussed. Yeah, relative permittivity and dielectric constant we discussed. Electric field we were in the topic. Okay. So electric field when we were calculating, we calculated due to ring, isn't it? And ring is having what? Distribution of charge. It's not a point charge, isn't it? Okay. So at the center, what happened? The field is coming zero, and on the axis, what we had the field? It was coming kqx by r square plus x square to the power 3 by 2. Now, on the axis, if I ask you what should be the distance or where the point should be lying on the axis so that field is what? Maximum. Please tell me at what distance on the axis the electric field is going to be maximum? Can you tell me? For electric field on the axis, we want to maximize it. Okay? So what we should do it, tell me. So should we do it d by dx? Please tell me. We want electric field on the axis to be maximum, na? So that means d by dx should be what? 0, isn't it? That is the condition of maxima,
Yes, sir.
right? So d by dx is going to be 0. So if you can, you just differentiate it, isn't it? D by dx of k q x by r squared plus x squared to the power 3 by 2. So if you differentiate it, what will happen? K is a constant, q is a constant. It will come outside. And if you differentiate it, can we apply u by v rule? Tell me, numerator by
Yes, sir.
denominator rule, isn't it?
Denominator.
So, so what it will be? It will be denominator squared,
Whole power.
right? Denominator whole square. Then what we have? Denominator outside. That means r square plus x square to the power 3 by outside. Differentiation of x. That is 1 minus x outside. Differentiation of r square plus x square to the power 3 by 2. So how much it will come? That will come
3 by 2
3
into
by 2 r square plus x square to the power 3 by 2 minus 1. So 1 by
1 by
2.
2.
And
2x.
again, if I apply the chain rule, the r square differentiation 0 and x square differentiation 2x. This thing should be what? Equal to 0. Got it? Please tell me. We
Yes,
got
sir.
the differentiation, and to get the maximum, the differentiation should be what? It should be equal to 0. So now just check it. Almost everything is outside, isn't it? R square plus x square to the power cube outside. Here also you can take something common from the numerator also. What we can take common from the numerator? R square plus x square to the power 1 by 2, we can take it common. So what I am left with, just see that. Are we left with r square plus x square minus, see that 2 and this 2 got cancelled out, isn't it? And 3x square we have.
3x square.
That thing should be equal to 0. Understood? So what are we getting? This thing cannot become 0, na? Check it. This is not having any possibility of becoming 0. So the second bracket should be 0. So what we are having? R square minus 2x square should be equal to 0. So what are we getting? X equal to plus minus r by root 2. Understand? This is a very important result, that if you are calculating field due to ring, then what will happen? At x equal to plus minus r by root 2, the electric field is going to be what? Maximum. Is that clear? On the axis of the ring, the field is maximum at what?
2 point.
2 point. X equal to plus r by root 2, x equal to minus r by root 2 also. Okay. And what will be
Yes,
the
sir.
maximum value of electric field? So we already know field expression, we know, isn't it? We know the expression of field. If I put the equation x equal to r by root 2, what will happen? We will get the maximum field, right? So what is going to be the maximum field? Is it going to be kq in place of x? Let me put it r by root 2 divided by r square plus x square. X square means r square by 2 to the power 3 by 2. So this is the maximum value of the field, and the maximum value of field will come where? It will come at x equal to plus minus r by root 2. Is that clear? So sometime they can ask you, draw the graph of the electric field and at all the points on the axis. How can you plot it? Tell me. Let's say this is the ring given to us, okay? This is the ring given to us. This is the center of the ring, and we want to see the variation of electric field as we go from center to both side of the ring. Then how the variation will take place? See that. Let's say this is the x-axis. X-axis is the axis of ring in this question. Can you tell me? And this is our y-axis. Okay, on this y-axis we are going to represent the field, and on the x-axis we want to see the variation. Please tell me how the field will look like. And towards right, we are considering as what? The positive. We are considering towards right as what? The positive. So please tell me how the variation will look like. X equal to 0, which means it's a
First
center.
it will rise and then it will decay.
Yes. Is that 0? So will it start rising from x equal to 0? It will reach a maximum value, and then again at infinity the value will become what? 0, isn't it?
Zero.
At very far away, so it will become 0 only, na? And what kind of graph the other side will come?
It will go
Is it
downwards and then
exactly mirror image graph will come the other side also? And
yes, sir.
what are these 2 points? Isn't it these 2 points are corresponding to maximum value of field? So can I
Plus or
say this
minus
is
R.
r by root 2 and this is minus r by root 2? Please tell. Clear this one?
Yes, sir.
Please tell me all of you. Clear? Now, few more things we can discuss in this one. We got electric field on the axis now. I'm going to apply the two condition. Okay. I'm going to apply the two condition. What are the two conditions? See, what is the expression of electric field on the axis? Electric field on the axis we have kqx by r square plus x square to the power 3 by 2. Now, if I take x very less than r, what does it mean? Listen me. What does it mean? X very less than r. Does that mean the point is very close to the center? Does that mean the point is very close to the center? Isn't it? So can you tell me what is the
Yes.
field will come? So can I write the field will become kqx divided by x is very small. So r square if I take it common, will it become r cube? R square to the power 3 by 2 r cube and 1 plus x square by r square to the power 3 by 2. And after binomial approximation, can I write it kqx by r cube? Please tell me. Net field on the axis if the point is very close to the center. What is the field we got it? kqx by r cube. And if I take the approximation, x is very greater than r. X is very greater than r means what? Far away on the axis. Understood? X is very greater than r. That means far away on the axis. Will I get it kqx? And this time x is very greater, na? So you will take it x square common. It will become x cube, isn't it? And then it will become 1 plus r square by x square. It will become to the power 3 by 2. So what we are getting the net field? Are we getting kq by x square getting? So check it. For
Yes,
far
sir.
away distance, is it just behaving like a point charge? The ring is just
Yes, sir.
behaving like a point charge. Please tell me all of you.
Yes, sir.
Did you get it? That if the point is very close to the center, then the field comes as what? Field comes as kqx by rq, and if the point is very far, it comes as kq by x square. So both the condition is very important. This condition we will use it many times when we are going to solve the simple harmonic motion. And this is not much useful, but let's say sometime if they are asking you in the question, then you should keep in mind these two result. So please tell me field due to ring. Are we clear about the field due to ring? Please tell me. Enter, it is 0 plus x squared to the power 3 by 2. Graph is also clear. Please tell me, bacho, is it clear?
Yes, sir.
I'm getting only one response. All of you are
Yes,
getting or
sir.
not? Please tell me. Okay. Now let's discuss about the field due to disk. Okay. The second we are going to discuss is electric field due to disk, uniformly charged disk. Okay. Uniformly charged disk. What kind of charge distribution will be given in the case of disk? Linear charge density or surface charge density? Thin disk. Okay, now what
Surface
kind
charge
of charge
density,
density?
sir. Surface charge.
Surface charge. We represented by what? Sigma. What is the sigma?
Sigma
Sigma is charge per
charge per
unit
unit.
area, right? So now let's calculate it again. What are the 2 points we are going to calculate it? The first point is going to be our at center. So at center, can you tell me how much will be the field coming?
Field,
Tell me
sir.
how much will be the field? Yeah,
Field will
electric
be zero.
field at the, how much it will come?
Field
It
will
will
be
come
zero at center.
zero again.
Yes.
At the center, it will be zero. Why? Because all the field will be cancelled out, na? Right? Now, next we are going to calculate on the axis. Okay, next we are going to calculate it on the axis. So on the axis, if I want to calculate, what I will do it, tell me. This is a disk, right? So in case of disk, the distribution of charge is what? The distribution of charge is
Area.
along the area, over the area. So what kind of element I should choose it?
Ring.
In
Ring.
case of disk, ring element, we should choose it, correct. So this disk is what? Having total charge what? Total charge is Q, and radius of this disk is what? Radius of this disk is R. So that means, can I say sigma is going to be Q divided by pi R square? First, we are going to write it in terms of sigma. Later, if we want, we can convert it in terms of Q. Okay. But it will be better if we write our formula in terms of what? The sigma. So first thing what I should do it, I should consider a ring element, a small ring element. So what will be charge on that small ring element? dq. First of all, tell me what will be the charge on that small ring element dq. Is that dq is going to be charge per unit area. Sigma is the charge per unit area into what is the area of the ring? Is the area thickness, a small thickness? Is it going to be 2 pi r dr? Please check it. Please check it. The ring
Yes,
is
sir.
there, na?
And
If you cut this ring and spread it, isn't it the area of that ring on which the charge is distributed is 2 pi r into dr? So that is the dq for us. Okay. Now I want to calculate field here, which is x distance from the center. So tell me, if I want to calculate field which is x distance from the center, for the ring element, this point is what kind of point? Is it an axial point? And do we know field on the axis of a ring? A small amount of field on the axis? Please tell me, do we know the field on the axis of a ring? Kqx by r square plus x square to the power 3 by 2? Please tell me. Kq r square plus x square to the power 3 by 2, isn't it? So can I write it? It will be k dq by Radius of the ring is r, so r square plus x square to the power 3 by 2. Now we want, and this field will come in which direction? Is this field is going to come axially? So all the ring elements are going to create the field axially only, na? Please tell me. So net field on the axis is going to be how much? If I want to calculate net field on the axis, should we integrate that? So K dq. What is the dq? Is the dq is sigma into 2 pi r dr? Please tell me. dq is sigma into 2 pi r dr, and denominator what we have? R square plus x square to the power 3 by 2. And the limit of integration? It's a complete ring of what radius? Capital R radius. So 0 to r we should do the integration. Please tell me up to this part is clear? Please tell me up to this part all the points are clear?
Yes.
So if we continue, k is constant outside, sigma is constant outside, pi outside. We have the integration of 2r dr divided by r square plus x square to the power 3 by 2. Can this integration be done with the help of substitution? Like if I consider r square plus x square as z, the 2r dr will become dz. Please tell me, this integration how you will do it? R square plus x square you will consider as something z. The 2r dr will become what? The dz, isn't it? So that becomes the integration of dz by z to the power 3 by 2. So k sigma pi, and what is the integration? So z to the power minus 3 by 2 dz integration is there. So z to the power, how much it will become? Z to the power minus 1 by 2 it will become. Please tell me, z to the power minus 3 by 2 dz is there. So z to the power minus 1 by 2 it will become. Please tell me. So z to the power minus 1 by 2, that means r square plus x square to the power minus 1 by 2 divided by minus 1 by 2, and limit will go from 0 to r. So please check it. What are we getting? K sigma pi, right? Minus 2. And now I am going to put the limit. So upper limit if I put it, what I am getting? Upper limit if I am putting, then are we getting 1 by r square plus x square? And lower limit if I put it, so that is coming 1 by how much? X square under root, isn't it? So 1 by x we got it. Please tell me, limit is going to be for the r, na? Let's send this minus 2 inside. So are we having k sigma pi 2, right? And let's multiply. See, is this part clear to us? Please tell me, is this part clear? So what we are getting? 1 by x minus 1 by x minus 1 by under root of r square plus x square. Please tell me, is this part clear?
Yes, sir.
And if you look at the diagram, what is this angle theta? If I call this angle as theta, see that if you look at the diagram, can you write it? Cos theta is x by under root of r square plus x square. Please tell me, cos theta is. So what I'm going to do it, I'm going to just take it. K value, what we can write it? 1 by 4 pi epsilon naught, isn't it? K value 1 by 4 pi epsilon naught sigma 2, and if you take it x common, right? If you multiply, check it once na, r square plus x square is z na, 2 r dr dz, dz by z to the power 3 by 2. Okay, the 2 by, if we put the limit, what are we getting after putting the limit? Please check. Please check my calculation. Is it fine? Upper limit we put it, so it become 1 by under root of r square plus x square. Lower limit we put it, so 1 by x square. So can we take it here x common, or you can just keep it like 1 by x. Let's multiply x and just one moment. Please check it. Is the calculation is fine? Oh wait, I think kqx is also there. Now one more here. K dq x will be also there. Now what happened today? No response
Yes,
coming.
sir. Yes, sir. KDK అంటే.
All of you well or what? Any issue?
No, sir.
This x we forget to write na. This x. So here is also x. So you send the x inside. So what it will become? X by x and
Minus
x by this one. So 1
1 by.
minus, is that the cos theta?
Yes, sir. 1 minus 1.
Right? And here k sigma 2 pi. So you see that something will get cancelled out. Do we have sigma by 2 epsilon naught into 1 minus cos theta? This is the net field on the axis of a disk. This is the net field on what? On the axis of a disk. Clear? Again, for large disk, for large disk, what will be the result? See that if the disk is very large, what will happen? See, if the size of disk keep on increasing, is the theta value will keep on increasing? Please tell me. If the size of disk keep on increasing, then can I say the theta value will keep on increasing? And for very large disk, can I say the theta is going to be 90 degree? So what is the field on the axis of a very large disk? Have you seen this result somewhere else? Is it the field due to infinite disk, or is it the field due to infinite sheet also? Infinite thin sheet.
Yes, sir.
Please tell me, field due to infinite thin sheet comes the same, na? Sigma by 2 epsilon naught only, na? Clear? So that was the second thing. Second
Yes,
thing,
sir.
first thing what we have done? First thing we have done, field on the center of the ring on the axis of ring. Second thing we have done, field on the center of a disk and on the axis of the disk. Okay? Please tell, clear? So sigma by 2 epsilon naught into 1 minus cos theta, we can use it. Now the third case we have, let's calculate field due to uniformly charged wire, thin rod. Now you will say, sir, what will be the field due to the cylinder or a sphere? So for cylinder and sphere, like for symmetrical arrangement, what we will do? We will use it the Gauss law to calculate the electric field. Okay, what we will do? We'll use the Gauss law to calculate the field. Okay, because the more and more complicated shape will be there, what will happen? The field calculation will get further complicated with the help of integration. So that's why for the cylinder and the sphere, for these two shape, what we will do? We will take help of what? Help of the Gauss law to calculate the electric field. Okay, due to hollow cylinder, solid cylinder, two cases, hollow sphere, solid sphere, two cases. Okay, please tell me, is that part clear?
Yes, sir.
What happened today? Very low response I'm getting. What happened? Is it very difficult? Please tell me.
No, sir.
Then what happened? Hmm? Any problem? Please tell.
Nothing.
Done.
Okay. So let's see the third case, that is the field due to electric field due to uniform or uniformly charged wire. Okay, charged thin wire. Again, thin wire, or sometimes they will use the word thin rod. Okay, what will be? Now tell me, can you tell me what kind of charge distribution here it will take place? Linear or surface?
Linear.
Linear. Lambda, है ना? Charge per unit length. Here, what kind of charge distribution?
Then
We charge will be distributed on the length of the wire. Okay. Now let's calculate it. What will be the field? Okay. So let's say there is a uniformly charged wire. Okay. First I am calculating for the finite one, and then we will calculate for the infinite also. Whatever we calculate for the finite, na, just a special case will be the infinite one. Okay. So let's say a finite wire is there. Length of the wire is r. Acha, please tell me, can I calculate for the unsymmetric point also? Please tell. Or only symmetric point?
symmetric point.
You tell. Or should I discuss with you unsymmetric point also? What will be the calculation?
Sir, unsymmetric point, then we can do it for both symmetrical.
Okay, chali, let's see. I'm going to take a point here, somewhere here. Okay, that point is what? That point is r distance from the r distance. This r is the perpendicular distance of the point from the wire. That's right. This r is what? It is the perpendicular distance of the point where we want to calculate the field from the wire. So what we should do it? Can we divide this rod into many small part? So what I did, at a distance x, I considered a small element of what thickness? Something dx thickness. So first of all, tell me, what is going to be the dq? What will be the charge on the small element? Is that going to be charge per unit length into the length of element?
Yes.
Right now, unitary method, lambda is the charge per unit length, and the element I have considered has a length of dx. So it means this small element I have considered, this small element has what charge? This small element has dq charge, which is equal to lambda into dx. Now, next step will be what? Calculating the field due to this small element. Okay, next step will be what? Calculating the field due to this small element at this point. So what kind of field will come? It's a positive charge, na? The field will be coming away. How much is that field? Let's call it d, because it is due to the small element. So what is the value of de? So can we write de is going to be k dq by distance of that point to the element charge. So what is this distance? Look at that. This is r and this is x. So can I say this distance is r square plus x square? So here what we will write it, under root of r square plus x square. So k dq by distance square. Please tell me, is it the field due to the small element? But can I directly integrate it now? No. Why not?
No, sir.
Because these all the element will create field in different directions. How can we add the vectors which are in different direction? So what we will do it, before starting my integration, I am going to take the component first. So please tell me, if I consider this angle as theta, so this angle is also theta. So that means this field is going to have two components. One component is d cos theta, and other component is what? De sine theta. Now, d cos theta is which component? So d cos theta is the component of field which is perpendicular to rod. And d sin theta is which component? Along the rod or parallel to rod. Isn't it? So now I am going to integrate these two components separately. Okay. These two components we are going to integrate it what? Separately. So first let's calculate it. What is the perpendicular component? So to calculate the perpendicular component, what we should do it?
So the
So we have the
perpendicular
two
one will get
component
cancelled.
for, yeah, please tell me.
The perpendicular component will get cancelled now, so we can directly only take the along the.
Perpendicular will get cancelled out. Check it. Perpendicular, so no chance it get cancelled out. Along can cancel out if it is symmetric one. That too in the case of what? The symmetric arrangement, what will happen?
Okay,
Along
okay,
will
yes,
get cancelled out. Perpendicular will remain there, isn't it? Why? Because the other
yes.
element will create field like this. Again, it will have two component like this.
Sir,
So there
perpendicular
is a
means
chance
d sine
of
theta. Sir.
perpendicular means d cos theta. Perpendicular means perpendicular to rod,
Okay, perpendicular to that.
perpendicular
Okay,
to
sir.
wire. Yeah,
Yes.
with respect to wire. Because wire can be horizontal, wire can be vertical, wire can be some angle. So how do we decide perpendicular and parallel component? So as a
Yes.
reference to the what? Reference to the wire. So you can write it reference to the, or you can say with respect to wire orientation. Okay. This perpendicular component I am calling with respect to wire orientation.
Yes.
Clear? So please tell me what it will be the perpendicular component. So can I say perpendicular component is going to be DE cos theta? Please see, results are simple. I can directly write the result. But why I am discussing with you these concepts so that if the charge distribution become variable, that time you will need this method to calculate the field. Okay.
Okay.
So DE cos theta integration. Now let's put the value. DE. D is what? K dq. dq means lambda dx divided by r square plus x square, and we have the cos theta, right? Now if you look at the situation here, now there are three variables involved here. Not three variables, sorry. There are two variables involved here. X is also a variable, है ना? X is the variable and theta is the
Theta is
variable.
also.
So can we bring it into single variable? So it is always better to bring the integration in trigonometric variable instead of keeping the algebraic equation, because integration
Yes.
of trigonometric functions are much more easier
Is
compared to
easier
what?
than math.
Algebraic function. Is that
Math.
clear? So
Yes.
look at the diagram and tell me what is the x and theta relation. Check it, the x and theta relation with us. So please tell me, can I write it tan theta equal to x by r? Look at the diagram. Look at the diagram.
Yes.
Tan theta
R
can,
tan theta equal.
so tan theta we can write it as x by r, isn't it? Okay. So x will become r tan theta. So dx will become what? R tan theta differentiation sec square theta d theta. So dx we have r sec square theta d theta. And one more thing you can see in the diagram, that is cos theta equal to r by r square plus x square under root, isn't it? So you can also write it r square plus x square we have as r square by cos square theta, that means r square sec square theta. Now the equations is simplified to get the answer. Okay, so see, the perpendicular component will become k lambda, dx is r sec square theta d theta, Denominator r square plus x square. R square plus x square, we got it as what? R square sec square theta, right? R square sec square theta, and another cos theta is there. That cos theta comes from the component, isn't it? That cos theta we got it from what? The component. Okay. So this is r square sec square theta and cos theta integration. See that, is it getting cancelled out most of the thing? Sec square theta got cancelled out, r got cancelled out. That means k is constant, lambda constant, r constant. It's just the integration of what? Cos theta d theta with us. And that is a very simple integration. Cos theta d theta gives us the sine theta. What will be limit of integration? Limit of integration means what? What is the ends of the rod? Where is the ends of the rod? Okay. Limit of integration means what? Where is the ends of the rod? So one end of the rod is here. Let's say it is making alpha angle. Other end of the rod is here. Let's say it is making beta angle. So what we have, k lambda by r cos theta d theta integration is sine theta, and limit will be what? Can I write it? Minus alpha plus beta, or plus alpha minus beta. That also you can write it, isn't it? Plus alpha minus beta you can write, but both you cannot write it, isn't it? Isn't it? Plus alpha you can
Yes,
write
sir.
it,
Yes,
minus
sir.
beta, or plus beta if you're writing, then minus alpha you have to write it, because one angle is measured in the clockwise, other one is in the anti-clockwise. The cos theta d theta integration sine theta, and if you put the limit, it will become what? Sine alpha plus sine beta. So what is the perpendicular component? You got it. So perpendicular component is k lambda by r sine alpha plus sine beta. And what will be the parallel component? Now can we write it directly? Boliye, can we write it? For parallel component,
Yes, sir.
how much it will come? The parallel component will come k lambda by r. You can write it cos alpha minus cos beta, or cos beta minus cos alpha, anything you can write it. So that's why if you see, if it is symmetric arrangement means what? Alpha and beta are equal. So what will happen? Cos alpha and cos beta will cancel it out each other. So that's why for symmetric arrangement, what will happen? We will only have the perpendicular to rod component, no along the rod component. Clear? Along the rod, there won't be any component. Only component will come is what? Is the perpendicular to the rod. So let me summarize it and tell you one last time what we have done here. See, this is the rod, right? This is the point. And this is how the distribution of charge is there, which has the linear charge density. How much? It has the linear charge density lambda, and the perpendicular distance is r. Can you tell me how many component will come here? Two component. One is going to be the, what I will call this component? We will call this component as perpendicular one. How much it will come? K lambda by r. And what is alpha beta? Alpha beta is the angle made by the perpendicular line with the ends of the wire. Which one you are taking alpha and which one you are taking beta, that doesn't affect our answer. Okay? So k lambda by r. What next we have? Because it's addition, na? See that? It's addition of sine alpha and sine beta. So whichever order you want, you can take it as your alpha and beta. There is one more component, parallel component. Now tell me, parallel component will be in which direction? Downward direction or upward direction? You please tell me. Perpendicular component to clear, it's away from the wire because the wire is positively charged, right? Because the wire is positively charged, so perpendicular component we got it away. Parallel component which direction? Can you Think logically and tell me what will happen. Value we know that it's a k lambda by r cos alpha minus cos beta. Magnitude we know that it's a k lambda by r cos alpha minus cos beta. I want to know the direction.
Away from the wire.
Parallel component. Whether this line is the correct one or this one is the correct direction. See,
Sir, for the point above the rod, it's the above one, and for the point below that.
okay, let's see. I want to calculate at this point now. Think about it. Can I say whatever this component will create the field, if I have only wire here to here, is the parallel component will get cancelled because of symmetry? Please tell me. Can I say if it is symmetric arrangement, that means alpha and beta are equal, then can I say that parallel component will get cancelled out?
Sir, both will be correct.
Both will be? Please tell. Please tell once. Please tell me. So here what is happening actually, if there is symmetric arrangement, so this parallel component will get cancelled out. But as you see, there is some extra portion here, na? So this extra portion will try to create field which direction? Something like this. And if I want field in this direction, can I say if one component is like this, then the other component must be like this? So that is how we will decide the direction of what? The parallel component. Is that clear? So
Yes,
how
sir.
much is the value? I will discuss examples, don't worry. So parallel component will be how much? K lambda by r, and what it will be? Cos alpha minus cos beta. Okay. Now, one last one is there. Here, some cases will be there. If it is infinite wire, can you tell me what will be the answer? Let me discuss 2-3 example here. Please tell me first example or first special case. If it is a finite wire only, but the point is symmetric. Can you see that? Symmetric means what? Whatever is this angle, same is this angle. Then only now we will call symmetric. Here what we have, alpha and beta are equal. Can you tell me only which component will come? Only which component will come? So here, can I say we have only one component that is perpendicular to the wire. How much is that? K lambda by r sine alpha plus sine alpha, because here alpha and beta are what? Equal. Here what we have? Alpha and beta are equal. The first case what we took? First case we took it. This is the case what we have taken. Symmetric arrangement. Okay, this is what? Symmetric point. Second case will be what? Second case will be infinite wire. What does it mean by infinite wire? Infinite wire means what? That one end is extended to infinity and other end is also extended to the infinity. Now I want to calculate here. Can you tell me what will be the answer coming? Which component will come? Just first tell me that. Is the only perpendicular component will come? And will it come k lambda by r? Lambda is the charge density, r is the perpendicular distance, k lambda by r. And for infinite wire, what will be alpha beta? So here alpha and beta are equal to 90 degree, approximately 90 degree. So sine alpha is also 1, sine beta is also 1. Are we getting 2k lambda by r? And k value, if I put it 1 by 4 pi epsilon naught, are we going to get it lambda by 2 pi epsilon naught r? Please tell me.
Yes,
Field
sir.
due to infinite. What are we getting? Lambda by 2 pi epsilon naught r. Okay? Please tell me, for infinite wire, what will happen? Alpha and beta is going to be what? 90° each. So we will get the field as how much? Lambda by 2 pi epsilon naught r. Okay. Now
Yes,
third
sir.
case is the semi-infinite wire. Semi-infinite wire means what? One end is at infinity and other end can be what? One end is infinity, that means what? One angle is 90°. And other angle, if I take the point like this, then can you tell me here what will happen? This is the perpendicular component. This is the parallel component. So here both component will come. Can you tell me what is the here? So here one angle is 90, one perpendicular component will come. Will it come k lambda by r sine alpha? So one angle 90, sine 0, other angle is 0. So am I getting this one as lambda by 4 pi epsilon naught r? Parallel component. Is it also k lambda by r cos alpha? One angle is 90, other angle is 0. So cos 0 1, cos 90 0. So that is also coming how much? Lambda by 4 pi epsilon naught r. So what is the resultant field will come here? Is the resultant field is going to be this? Please tell me. And both components are equal. So can you say the net field will be root 2 times of lambda by 4 pi epsilon naught r? Please tell me. Please tell, is that clear? All of you, please tell me what happened today. All of you.
Clear, sir.
Hmm?
It's clear, sir.
क्या हुआ? What happened? Please tell me. So
Got it, sir.
understood what we discussed here today?
Yes, sir.
Please tell me.
Yes, sir.
Okay. So now just one small part is left, that is the field due to arc, circular arc. Then what we will do? We will combine arc and wire. We will combine and make some structure and find out what is the net field due to the structure we are going to get it. Okay. Net field due to those structure, how much we are getting, that is what we will calculate it. Okay. So please tell me, up to this part is clear?
Yes, sir.
So the tomorrow next class, what we are going to do, we are going to just first thing we will do is calculate due to the arc at its center. Okay. Electric field due to arc at the center. That is the one thing we will do. Then we will practice around 5 questions on that. Okay. Field due to ring and disk calculation, that we will practice. And then we will go for what? The one more thing is there, like electric field lines. And then after understanding the electric field lines, we will go for the Gauss law. And once we understand the Gauss law, then what we can do, we can apply the Gauss law to calculate electric field due to some more structure is needed, like electric field due to the cylinder and a sphere. That using the Gauss law, we will calculate it. So up to this week, our topics will be tomorrow. Topic will be field calculation due to circular arc at its center and combination questions. After that, we'll go for the Gauss law, and with the help of with the help of Gauss law, we can calculate the field due to some distribution of charge. Okay, so this is going to be our this week further topics. Okay. Please tell me, do you get it what we discussed today? So in this one, ring part is more important. Okay, ring part is more important. Disk, very few questions will come. But ring, there are many questions and many application. Ring and rod part. Okay. Rod also many questions are there. Okay. So please tell me, all of you, fine?
Fine, sir.
Please tell me. Okay. So let's meet it tomorrow. And
Yes, sir. Okay, sir. Charan, can you send me maths notes for the last two classes in WhatsApp?
Yeah, sure.
Thank you.
okay. Right, everyone.
Okay, sir. Thank you, sir. Thank you, Charan.
Okay. Let's meet it tomorrow then. Okay. Take care, everyone. And after tomorrow class, I will give you some work.
Bye, sir.
Bye bye. Good night.